Good morning everyone. I'm glad enough to meet you again in chapter 4, Heat, part 3. So today we will be ending this chapter, and maybe next class we'll start with a new chapter, new lesson. So far in this heat lesson, we have learned what is meant by heat, and we have also learned about what is meant by temperature. We have learned about the 3 scales of temperature like Celsius, Fahrenheit and Kelvin. And you all know that the Kelvin is the SI unit of temperature. We have also learned about the different types of thermometers like Celsius and Fahrenheit. Then secondly, we have learned about mercury and alcohol, and at last we learned about clinical, laboratory and the minimum and the maximum thermometers. We have also learned about how to measure or how to handle a thermometer, or how to take a reading of temperature using a thermometer. We are at the end of this lesson. So as I said in the last video, this lesson divided into 2 segments. First segment deals with the heat, temperature and thermometers, and the second segment deals with the transfer of heat. So this you might have learned in 6th standard or lower classes. Transfer of heat, that is based on the medium, the transfer of heat classified into 3 types as conduction, convection and radiation. For ease understanding, I put it this way: if heat is transferred through solids, it is called as conduction. If heat transfers through fluids, it is called as convection. And if there is no medium at all, that is in vacuum, if heat is transferred, then it is called as radiation. So now we will enter into today's class. So last period we have completed about conduction. In that we have learned about 2 types of conductors, that is good conductor and bad conductor. If heat is transferred through a medium, passed, or if heat is passed through a medium, it is called as good conductor. If heat cannot be transferred through a medium, then it is called as bad conductor. Okay. So today we are going to learn about convection and radiation. That is, we are going to learn about transfer of heat through fluids, that is convection, and transfer of heat through vacuum, that is radiation. Before I enter into convection and radiation, there are some few topics that has to be completed under conduction. So we will discuss that, then we will go to convection and radiation. First, 2 experiments are there to prove air and water are not good conductors of heat. First, let us start with air. So for this, you take a glass tube, empty glass tube. Inside you take an ice cube covered with the wire gas. You just keep it inside the test tube and heat the neck of the test tube with a burner. So before heating, close the test tube with the rubber cord tightly. Now when you heat the test tube near the neck of the opening of the test tube, after some time you will find the cord coming out of the test tube with a pop sound. This shows that the heat is transferred through air, and that made the air to expand and pushed the cord outside, whereas that air did not pass downwards and there was no melting of ice. And this shows air is a poor conductor of heat, or I could say it is a bad conductor of heat. The second experiment is to prove that water is a poor conductor of heat. For this, again you take a test tube, take some water, similarly like how you did in the previous experiment, take an ice cube covered with the wire gas and put inside the test tube, keep inside the test tube. Again you heat the test tube near the layer of water, near the surface of the water. Here also you could find one thing, that is the ice does not melt in both the cases the ice does not melt. And here this experiment shows, since the ice did not melt, it shows that water is a poor conductor of heat. Okay, from these two experiments we understand that air as well as water are not good conductors of heat. You can also use wax instead of ice cubes in these two experiments. Okay. Next, we are going to learn another important topic, that is the practical applications of conductors and insulators. First, let us learn some few examples of practical applications of conductors. That is, first of all, in thermometers, mercury is used, which is actually the transfer of heat in a metal, which is a practical application of conductor, where we use this concept of conduction or concept of good conductor with regard to this reading of temperature. That is the first application. Then all the vessels come across that is used in cooking are all made of metals, which is also an example of good conductor of heat, or which is an example of conduction, transfer of heat through solid. Then third, in case of this refrigerators and ACs, we have this coils, cooling coils, where we come across conduction of heat. So that coils are very, very important, which are made up of copper, and which helps in the maintaining the temperature inside the room and transferring the heat outside. In that way, that cooling coils that are made up of copper are the examples of the third example of conductors, practical application of conductors. Then fourth, in case of this automobiles, especially in vehicles, 4-wheelers, 6-wheelers, where you come across again cooling coils which are made up of copper, and that is also a practical application of conductors or transfer of heat. All these are good conductors of heat, and they involve in the transfer of heat. Either they helps in reading the temperature, example mercury, or in transfer of heat throughout the food, example cooking vessels, or in emitting the heat away from the engine, example cooling coils of engine, as well as cooling coils of refrigerator and ACs. Similarly, we also have practical applications of insulators. First comes in cold countries like European countries or in Russia, where you come across these glass windows which are made up of two panes. There will be two glass panes inside which you have air inside. This air, since we have just now learned, air is a poor conductor of heat. It helps in the maintaining of temperature inside the house. And we have the windows outside, surrounding the house. They maintain the air that is trapped inside the windows. They help in maintaining the temperature inside, and they don't allow the air outside. That is, warm air inside the house outside, as well as it does not allow the cold air from outside to enter into the house. So in this way, air, which is a good example of insulator or a poor conductor of heat, is used in our day-to-day life. The second application of insulator that is used in our day-to-day life is when you go to Ooty or Kodaikanal or Kashmir, where you come across this bed covers will be in a bulk, thicker. So actually, we call this as quilt, which comprises of 2 or 3 layers of cloth with air space. This is called as quilt. And this is again another example for insulator, where the air maintains our body temperature when we cover, when we sleep. Okay, so this is a second example of practical application of insulator. Then third, with regard to igloos, when you look into igloos, you will find the igloos inside your air trapped inside. Where again, when persons living inside igloos, hope you know, igloos are houses made of ice and straw. Okay, when air is trapped inside, this air helps the persons who are living inside or staying inside to maintain their body temperature. So that is the third application of insulator. Okay, air being an insulator. Then 4, in case of bigger blocks of ice, bigger ice that are used in industries or factories, where you would have found somewhere the ice are covered with some gunny bags. So that this gunny bags helps the ice, or it helps to maintain the temperature of the ice, such that the ice does not melt easily. Because gunny bags, you find air inside, like how you have sweater. This gunny bags, you can find air inside or in between the fibers that helps to maintain the temperature, or that helps to such that the ice does not melt. Okay. Then with regard to this cookware utensils, you find the handles of cookware made of a plastic named as bakelite. I hope you know there are 2 types of plastic, thermoplastic and thermosetting plastic. So in that thermosetting plastic comprises of 2 types, bakelite and melamine, where bakelite is a bad conductor of or a poor conductor of heat, and that's why the handles of cookwares are made up of bakelite, which is a kind of plastic, and it is a bad conductor of heat, such that you are not disturbed when you handle the cookwares. The heat of the vessel will not affect you. That's why handles are made up of special plastic called as bakelite. Now let us learn about the second transfer of heat, that is convection. So far we have learned about conduction, that we learned more about conductors and insulators, practical applications of conductors and insulators. Now we will go to the next second topic, that is convection. So you know very well what is conduction, the transfer of heat without the actual movement of molecules or particles is called as conduction. It takes place in solids. You know very well why there is no actual movement of solids, because we said in last period, solids, they are placed very close to each other. I mean the particles or the matter found in solids are placed very close to each other, so there is no movement of molecules. So that's why conduction takes place. And here in convection, you find molecules far away from each other. For example, in case of liquids, the molecules are far away, whereas in gas, the molecules are very far away from each other. And I think we discussed about this in previous class. So that is the nature of liquids and gases. And that's why convection takes place, and when convection takes place in fluids, either liquid or gases, come across the movement of molecules, transfer of heat by the actual movement of molecules. That is the definition of convection. Right. So let us read some 2 examples, 2 activities for convection. For this, first let us take a round water flask. In that you take water, more than half of flask should be filled with water, or 3/4 of the flask should be filled with water. I keep this flask on a burner setup. I just before starting to heat the flask, I just drop 1 or 2 potassium powder crystals. So when heat is transferred, what happens, the water starts to boil, and you can find inside the potassium carbonate molecules slowly dissolve in water, and the molecules move upwards and then they move towards sideways. This shows heat is transferred or convection takes place by the actual movement of molecules. I hope you understand. So this is a good example for this is a good example to do convection. Similarly, one more experiment with air. That is, you just take a candle, light it up, and keep your hand above the flame. Okay, be careful. Okay, if you are trying at home, be careful. Don't put your hand in flame; it will hurt you. It should be above from the flame, and keep a hand any one of the side of the flame, adjacent to the flame. See to that you don't touch the flame, so because you know flame will be hot. Okay, so one hand above and one hand on sideways. So you can find hotness on the hand which is above the flame, and you not that much hotness or no hotness at all in the hand which is placed sideways. This shows that always heat in air is from bottom towards top. So you can also, you don't need to put your hand, you can also observe a flame. You can find when the wax is melted and when the candle burns, you will find the gas moving upwards. I hope you might have noticed. This shows that hot air always move upwards, not in the sideways. I hope you understand. So based on this, we are going to learn another two topics: land breeze and sea breeze. That is during daytime. For example, we are in Pondicherry, so this is my east. So I am standing here. For me, this is east. Where we have sea. Okay, for Pondicherry, sea is on the eastwards. So just put in mind land and the sea. Okay, so land is there, sea is there. So that is during daytime. The land will be more hotter than the sea. Okay, keep that in mind. Land will be more hotter than the sea during daytime. And during night time, the air above sea will be more hotter than the land. Because in morning time, the air above the land will get more transfer of heat. So more faster or more heat will be there compared to the air above the sea level. But in night time, the heat in the land will immediately start to move away. So such that in night time the air above the sea will be hotter compared to the air above the land. This is one concept. Okay. And one more concept with regard to this breeze. A gentle air is called as breeze. So you might have gone to a terrace or near a beach or somewhere where you come across air touching you or air moving, and that is called as breeze, a gentle air. Okay. So there is a song in Tamil, old song, antique song. காற்று வந்ததால் கிளைகள் அசைந்ததால் கிளைகள் அசைந்ததால் காற்று வந்ததால். You might have heard or at least now you browse that song and hear that. So this is a question. You should have this question by this time. Whether you get the breeze or wind because of the movement of branches of trees, or since there is wind, branches of trees are moving. So science, we are in science. So science says both are possible. When there is a wind, you come across the movement of branches of trees. Similarly, the so-called fans that are made up of manual fans that are made up of palm leaves. So if you move that palm leaves, so even in that case you get wind. So when wind comes, branches can move. Similarly, when branches moves, you get wind. So both are possible. Okay, coming to the point. So basically, you come across, first let me say what is the reason for this wind or breeze. So you just take the vast area of land. Okay, so I don't say in kilometers. I'm not telling you now numerical measurements. So, but imagine a vast area of land. Maybe the whole Nagar or the whole Pondicherry. Okay, like that. You imagine a vast area of land, especially during summer season, where you come across hotness. The air becomes hot. The air above the land surface gets hot. And usually hot air will be denseless or weightless. So automatically, wherever you apply, it's not only in atmosphere, you may apply inside a cooking vessel or it may be a burning candle. Everywhere you come across hot air or smoke always moving upwards. Maybe you might have noticed the smoke. And this movement is because of this reason, that is hot air is denseless or weightless. Automatically hot air will move up. So coming to our concept. So I said a vast area of land during summer season, because of the high temperature, air becomes hot, and that hot air, since it is denseless, it starts to move up. To balance this lack of air in that particular area of land, wind that is outside this area, not wind, air that is outside the area will start to move inside, and that is what we call it as wind or breeze. And this is the reason for wind or breeze. So automatically when the wind blows inside, branches starts to move. Branches of trees will start to move. Okay, right. So this is the concept behind this air or wind or breeze. Okay, not air, wind or breeze. So that's why we get wind. It's because of the movement of hot air towards upwards and the cool air getting inside. One. Now coming to this concept, land breeze and sea breeze. So during morning time, the air above the land surface will be hot, and because of that, air will start to move upwards. So the air which is cooler than this land, okay, which is cooler than the air above the land, that air will start to move inside, and this we call it as sea breeze. Since the air above the sea moves towards the land, this breeze is called as sea breeze. But at night time, the air above the sea will be hotter compared to the air here, because already you have learned just now the hot air moved upwards. So automatically you will find low temperature during night time. So that is air above the sea, which is warmer than this air, will start to move towards the land. But during night time, the air above sea level will be hotter compared to the air above the land. So what happens? That air will start to move up. That is, the air above the sea will start to move up, and automatically to balance the lack of air above the sea level, the air above the land surface will start to move towards the sea, and so this we call it as land breeze. Morning time, air above the land will be hotter, so it starts to move upwards. To balance that, air above the sea will start to move towards the land. Since it is from the sea level, it is called the sea breeze. But during night time, the air above sea level will be hotter compared to the air above the land. So what happens? That air will start to move up. To balance that, air above the land will move towards the sea. And since the air is moving from land towards sea, this is called as land breeze. Our next topic is radiation. This is the final topic. Okay. So conduction, transfer of heat without the movement of molecules is called as conduction, which takes place in solids. Convection, transfer of heat energy by the actual movement of molecules is called as convection, which takes place in fluids, that is air and water, that is gas and liquids, better way, okay, gas and liquids. And now we are at the end of the lesson, radiation. What is radiation? Transfer of heat in vacuum or transfer of heat without any medium, that is air or gas or liquid or solid. Air, that is gas, liquid or solid. These three are called as medium. If there is no medium at all, then that condition is called as vacuum. Okay, so this is something related to sound, because sound needs a medium to travel. If there is no medium, sound cannot travel. Sound cannot travel in vacuum. Okay, so come to heat lesson. That is, when heat is transferred in an empty space or a vacuum, it is called as radiation. Best example is the solar radiation that reaches the atmosphere. Before reaching the atmosphere, the heat or light, especially we are learning about heat. Okay, so let me stick on to that. The heat from the sun reaches the atmosphere in a vacuum, and that is a good example of radiation, and that's why we call that as solar radiation. Okay, right. With regard to this solar radiation, question is there whether heat from the sun is through conduction or convection or radiation. So basically, you know, two concepts in two ways it can be explained. One, first of all, from the sun till the atmosphere, we don't have a medium at all. So that is the first reason to prove that solar radiation. It is not conduction or convection, but it is a radiation. One, because you don't have a medium at all in near the sun or above the atmosphere. Okay. Then secondly, if it is a conduction or convection, it should pass straight. It cannot move upwards, that means or sideways. Conduction, convection cannot move sideways, and so it should be radiation. So This is a question raised by many, or if you have a doubt in your mind, whether it might be convection or it might be convection, no, it is only radiation. For that I am explaining in two ways. One, you don't have a medium at all surrounding the sun. Only in atmosphere, above the Earth's surface, you have air or water molecules. So in that way, it is surely radiation. Similarly, it is not convection or convection, because here solar radiation will come across all over the area surrounding the sun. It is not in a one pathway. Because if it is convection or convection, especially convection, it is always in one way, not in the sideways. So this is a small proof that solar is a radiation. Okay. So there is an experiment to prove that this radiation is found in black objects than lighter objects or pale objects. In book they have given white objects. I use the word pale objects. Whatever that is pale, whatever that is not darker is called as pale. Okay. So why we are learning this experiment? Because based on this we have to apply certain things in our life. For example, you are not supposed to use a black or any darker cap during summer season, because this cap will absorb more amount of heat to your head and it may affect your brain. Similarly, you are not supposed to use darker shirts, especially black shirts during summer season, because you will feel more hotter compared to a lighter or other pale shirts. Okay, and it is preferable those who are living in tropical areas, especially in India, it is preferable that we don't buy a black color vehicle, especially vehicles like cars, vans, buses, etc. Because when you are buying a dark color vehicles, especially black color vehicles, this black color will absorb more amount of heat energy and you will feel hotter inside when you are traveling in those kind of vehicles. So for this, there is an experiment. What you do is that you take two cans, tin cans, fill it with water. One can is black painted, other is pale painted or white painted. You just keep this two cans with water in sunlight and insert a thermometer in both the cans and check the temperature after maybe 1 hour or 2 hours. You will find the temperature will be more in the black can. Based on the thermometer we are measuring this, okay, than the light can or the white can or the pale can. Okay, so this shows more amount of heat energy is absorbed by the dark color than the white or the pale color. Then again, you take the cans away from the sunlight, you boil both the cans, you heat both the cans to a particular temperature for some time. See to that both the cans reach the same temperature and keep the cans indoors somewhere aside without disturbing. And again you will see in both the cans the heat will be lost, the temperature will be lost, and here you come across the black can. In black can the heat is lost sooner than the white can. So from this you can understand heat is absorbed as well as emitted faster in black can compared to the white can. Now let us learn about the uses of good and bad absorbers of heat as well as uses of good and bad emitters of heat. Okay, so one by one we learn certain uses of good and bad conductors good and bad absorbers as well as good and bad emitters of heat. Okay. First, let me start with the uses of good and as well as bad absorbers of heat. That is, one, in tropical areas, especially we are in India, almost near the equator, where it is better to paint the houses with white color rather than any dark colors. If you go for dark colors, more amount of heat energy will absorb and you feel warmness inside the houses. So that's why you should not paint or externally as well as internally. It is better to paint a pale color rather than a dark color or a black color. Okay, so this is a use of good. This shows that this is a proof for good absorption of heat. Okay, if you go for black color, more amount of heat will be absorbed. If you go for pale color, very less amount of heat is absorbed. So it is better to go for a pale paint in our houses. Secondly, with regard to this cooking vessels, you will find the cooking vessels where the base will be black or dark in color, which is a proof to show that so that the vessel easily absorbs heat and the cooking will be faster compared to a vessel without a blackish color or a dark color. So in that way, we are applying this black coloration as a good and a bad conduction of heat. If you paint a light colored houses, it implies the bad conduction of heat. And if you find a vessel with a dark base, which means it is an example of good conduction of, good radiation of heat, conduction or radiation of heat. Similarly, with regard to uses of good and bad emitter, okay, so emission means sending out the heat from one particular object to, outside, okay. With regard to this teapots, if you find teapots, they are shiny in nature. This is just to maintain the heat inside the teapot. Similarly, second example, in case of car radiators, where you come across the radiator tubes will be blackish in color, and this is also to emit the heat away from the engine or from the radiator. So these are the four uses of good and bad conduction, good and bad absorption and emission of heat energy. Okay. As we discussed before, based on this, we have to go for different types of cloths. Okay. With that, I just want to say two things. One is we wear woolen clothes. I said before, we are not supposed to wear dark clothes during summer. Similarly, we wear woolen cloths, and where you come across air trapped inside the fibers. And that air only maintains the body temperature, and that air protects you from the external temperature. And last but not least, to end this lesson, one important concept, that is when you are using these blankets. Okay, so when you are using blankets, we discussed quilt. Okay, so where this quilt, I said, comprises of 2 to 3 layers. And what I am trying to say to end this lesson is, it is better to go for 2 to 3 layers of blankets. If you are not having a quilt, if you want to go for a single blanket, when you don't want to be affected by cold, okay, fine. So in that case, instead of going for one thicker blanket, it is better to go for 2 or 3 blankets at a time. Such that we are using one thick blanket, that I am not talking about quilt, okay, so I am talking about normal blankets. If that blanket is, even though it is thicker in nature, you will have the chillness, coldness inside. But at the same time, if you are going for 2 to 3 blankets at a time, using at a time, so that the air that is found in between the blankets, the 2 or 3, whatever you are using, that air maintains your temperature, and thereby that air, since it is an insulator, that helps you or that protects you from the external coldness. Maybe the AC in your room, or if it is a rainy season or winter season, you will feel more chillness inside the room, inside bedroom. Even though you are not using AC, you will find chillness under the fan. So in that cases, instead of going for a thick blanket, go for 2 or 3 thin blankets. The air that is in between these blankets, which is not visible to us, which cannot be understood by us, that helps us to maintain the body temperature. You will not get the coldness or chillness. You can sleep with a warm condition in your bedroom. Okay, thank you. With this, the lesson comes to an end. So we'll meet